bioelectronics. And we also have an R&D center in Hsinchu in the Science Park, which will focus on 3D technology, 3D IC, ultra-low power electronics, and also MEMS devices. Beside that, we have representation offices in Japan, mainland China, and the USA. Well, to give you some numbers, what's this vision about? Well, if I go back to the two dimensions I showed you earlier, if you look at the energy efficiency, the research impact we want to create is that by 2020, we want, compared with today's state of the art, our technology should be 2,000 times more energy efficient. If you look at our technology today, some of our building blocks, they are 10 to 100 times more power efficient than, for example, the state-of-the-art Bluetooth or DSP implementation. So we're still not there yet. We still have some years to go. The same counts for the data performance, the performance in general. There we want to achieve 30 times better performance than today's state-of-the-art. At the same time, devices should be ambient aware. They should make use of the scarce resources, unlike human beings who do not really communicate with each other and try to all use the same roads. That's called cognitive intelligent devices. At IMEC we have 4 distinct areas where we focus on, especially on the ultra-low power and the mobile wireless communication. One area is the cognitive aspect, where that we focus on algorithms and silicon technologies, how to make use of the scarce spectrum. The second area is what we call reconfigurable front-end, where that with one IC you can implement a multiple of standards. Then we have several kind of research in 3D IC technology, stacking different wafers on top of each other. We also do research for gigabyte per second wireless communication. And we really do a lot of effort already since 10 years on flexible processor templates. Finally, the fourth area is on ultra-low power. There we are developing an ultra-low power toolbox which allows us to innovate in certain areas like healthcare, which really require ultra-low power new concepts. Let me give you a few examples of that research which is in the pipeline. If you look at the cognitive aspect, this picture shows a map of today's wireless standards. And probably I forget a couple of them. Today in this room, probably a lot of intensive mobile phone communication or Bluetooth. But there's still a lot of unused spectrum. So if you have devices which can recognize this gap and can optimally make use of the spectrum, then you can make a difference. But that requires cognitive radios. That requires cognitive devices. Today, if you look at a mobile phone, but it could be another device as well, well, mostly, in most cases, each of those standards is implemented in one single IC. Okay, there are exceptions where people try to combine things, but in general, this is still true. Even the new ones in one IC. How to keep the flexibility? How to achieve time to market? Well, at IMEC, we developed what we call the software-defined radio. It consists of one baseband IC and one reconfigurable analog IC, which with software can support all the standards. Not only the existing ones today, but also the future ones, by just a push of button of the software. So gone all these ICs for WiMAX, Bluetooth, name it, just one single IC. This is innovation. Another trend is convenience. People are convenient animals, convenience-seeking animals. HD is booming. Blu-ray, cable replacement, ultra-fast download. I'm not sure in the back if you can read it, but